Okay, welcome to Chapter 3. We're in Section 5. We'll be dealing today with proving triangles congruent when they are overlapping. So our learning target today is students will use overlapping triangles in proofs. Overlapping triangles occur quite often in different types of triangles. At first, you may have trouble recognizing which triangles to use in a proof, especially when they are overlapping. Overlapping triangles often either share an angle or share a side. So let's take a look at this first diagram. We could see that in this diagram we may be proving that triangle ABC is congruent to triangle AED. However, there are some overlapping triangles here that we may be proving congruent. You may take a look at this and see these two triangles overlapping. Okay, and these two triangles then may be proved congruent. See how when they overlap and then pulling them apart, now these two triangles might be reflections of one another. In this next diagram, we may see several different pairs of overlapping triangles. We may pull them out from this top part. And you might be thinking, okay, well, I may be proving these two triangles congruent. Or perhaps there's some overlapping triangles here below, like this one and this one. So triangles could be overlapping several times within one diagram. Here's a third example of one we might see. This one's similar to the first one, except there's no top to the triangle. So again, I see two different pairs of overlapping triangles. Might be going after this pair right here. Or perhaps we may be going over this bottom pair right here. Just depends on what type of problem it is. Let's take a look at an example of a proof where we have some overlapping triangles. Here's one. We have some given information, and we're trying to prove that segment AD and BC are congruent to each other. So there are several different overlapping triangles here. We're looking for the one that will help us the most to get to our proof statement. Let's take a closer look. Once we mark this diagram, we see that the two angles are marked congruent and these full sides are marked congruent. We also have a reflexive angle at F. So it's a good idea to pull these triangles out and off to the side from your full diagram. And when you do that, you can see very easily the parts that you're going to use to prove these triangles congruent. In this case, we have two angles and an included side. So we'll be using angle side angle. When they're overlapping, it looks like this, and it's hard to tell that ASA, but when we pull them apart, it's really easy. So a great strategy to solving problems like this is to draw these triangles off to the side and mark them separately. Right? From the given information, we can then conclude that angle F is congruent to angle F. It's a shared angle by both of these overlapping triangles. We use the reflexive property for that. So that gives us our first angle. We have a side. Of course, we have the two triangles now, and we know that that's true by angle side angle. All right, if the triangles are congruent, we could say that FA and FB are congruent to each other by CP/CPC. Let's see where those two parts are. Those two parts would be right here. This guy and this guy. If two triangles are congruent, then their corresponding parts are congruent. Let's put that in our full picture as well. Now, to remember, we have to try to get side AD congruent to side BC. And why would these two segments be congruent? Well, looking at the full picture, we have the full left and right sides, and then we have FA and FB. So by segment subtraction, we can get the parts that we're looking for. Let's take a look at another example. This time we're trying to get these left and right segments congruent. We have some given information that angles A and angle 9 and angle 10 are congruent to each other. And then we have GFH and HJG. So after marking our diagram, we see that we have these markings congruent. And I went ahead and added an angle 11 and 12 in my diagram. I know that those angles are congruent to each other. Can you tell me why? And then finally, we have these double arc angles. They are given. So if 9 and 10 are congruent, given, we know that 9 and 11 are congruent to each other. And also 10 and 12 congruent to each other, combining these two steps. All vertical angles are always congruent. So if 9 and 10 are congruent, would 11 and 12 be congruent to each other? The reason to remember, transitive property. We have some overlapping triangles here, so let's separate these out and see what they look like. So much easier to see them once they're separated out. Okay, see if I can see it so we can all see them. Okay. Now, these two together make a full angle. All right, so when we separated them out, there was the 2 and the 1. So G, F, H, and HJF are the double arc angles. That's enough to give us these full angles out here, GFJ and HJF. That's going to be angle addition. So I didn't mark them, but you have a little double and a little single one. There's a ray in here, but we're not interested in that ray when we pull the triangles out. So now we have enough then. We have the reflexive shared side. See where it came from? F and J separated, but they're still congruent to each other by the reflexive property. And now we have enough for the triangle, so we can easily see that it's angle side angle. And of course, we want to get this side congruent to this side over here. And we know that if two triangles are congruent, then all of their parts are congruent, and that's by CP/CPC. So the takeaway on overlapping triangles is to identify those triangles and draw them off to the side so that you can see the parts necessary to get the triangles congruent. So hopefully this lesson will give you an idea of how to tackle problems with overlapping triangles. So I look forward to working with you in the classroom on these type of problems, and good luck.